cohesive force basically responsible for surface tension, tending to contract or to have minimum area. So the membrane contracts, it tries to possess minimum area. When you compare the surface tension of hot water, it is primarily less. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Yesterday's class, we studied Stokes' law, we studied the effects of viscosity, and we formulated the concepts in terms of question and answers so that it is easy for you to go through it. What was the effect of viscosity on liquids with rising temperature? When temperature increases, intermolecular distance will increase, which means proportionately viscosity of a liquid decreases. And for a gas, as temperature increases, rate of diffusion increases. Therefore, viscosity also increases. Now, in today's class, I have formulated the concepts on surface tension in terms of question and answers, which will help you to understand it better. The first question, students, what are cohesive forces? I told in my concept class, the word cohesive means same, coherence totira. If the wavelength of two radiations will be the same, we say that they are under coherence. If the frequency of two particles is the same, we say that they are under resonance. This is cohesive force. Force between molecules of the same substance is what we call as coherence forces or cohesive forces. So it is the force between the molecules of the same substance. That is what we call cohesive force, basically responsible for surface tension. The other 1 mark question asked is, what is adhesive force? And it is the force between the molecules of different substances. Force between the molecules of the same substance is called cohesive force, whereas the force between the molecules of different substances are called adhesive force. Now, this is very important. This is always asked as a 1-mark question. To define surface tension of a liquid. What is surface tension of a liquid? The answer is, it is the property of a liquid. Surface tension is the property of a liquid because of which the free surface of a liquid, the free open surface of a liquid behaves like an elastic membrane. Concentrate on the words I underlined. It is the property of a liquid because of which the free surface of a liquid behaves like elastic membrane, tending to contract or to have minimum area. So the membrane contracts, it tries to possess minimum area, or in other words, surface tension is also the tangential force acting on the free surface of a liquid. By property, the free surface acts like an elastic membrane, where the membrane contracts, tries to possess minimum area, and it is also the tangential force on the free surface of the liquid. And therefore, what is its SI unit? See, I told it is F divided by length. So this is Newton per meter. So this will be the SI unit of surface tension. Dimensional formula we have already written. It is M L0 T minus 2. Again, I repeat, the first section of the question paper, you will be asked to write the SI units or dimensional formulas for several physical quantities. You have to be in a position to answer that rigorously. The next one. Why is it easier to wash clothes in hot water solution rather than in ordinary water? Why is it easier to wash clothes in hot water solution rather than in ordinary water? The answer is, here the surface tension of a hot water solution is very, very less compared to the surface tension of ordinary water. When you compare the surface tension of hot water, it is primarily less when compared to the surface tension of ordinary water. So, easy to wash clothes in hot water when compared to cold water. The next one, again an assertion. Why small drops of liquid like raindrops are spherical in shape? The reason for small drops of liquid like mercury drops, raindrops are spherical in shape, that is because of surface tension. So what is the classical feature of surface tension? The liquid tries to occupy minimum area, contracts. Therefore, it assumes what is called spherical nature. A membrane which is contracting, a membrane whose area is decreasing. So students, liquid drops like the raindrops, the mercury drops are spherical in shape, are spherical in nature, basically due to the property of surface tension, where the sphere will try to acquire minimum area, it will try to contract. Therefore, it is spherical in shape. Next one. What is the effect of temperature on the surface tension of a liquid? Variation of surface tension of a liquid with respect to temperature. We say generally surface tension decreases with increase of temperature. See, these are all 1 mark questions. What happens to the surface tension of a liquid as temperature increases? The surface tension of a liquid decreases as the temperature increases. Similarly, you have seen the variation of viscosity with temperature in liquids and fluids. So what happens to the surface tension of a liquid with increase of temperature? As temperature increases, the surface tension decreases. Effect of impurities. Again, this is asked as a 1 mark question. Effect of impurities on surface tension. What happens to the surface tension of a liquid as impurities are added to it? If impurities are added, again surface tension decreases. So if the liquid is contaminated with impurities, if impurities are added to a liquid, then its surface tension decreases. So with increase in temperature, surface tension decreases. as impurities are added to the liquid, its surface tension decreases. Very, very important definition. Angle of contact. We have defined angle of contact. Angle between the tangent drawn to a solid surface and the liquid in contact with it. We have written cases for angle of contact for obtuse and acute angle, pure glass which is in contact with the solid, and so on. Capillarity, the phenomenon of rise or fall of a liquid in a capillary tube. Sudden rise or sudden fall of a liquid in a capillary tube. Blood circulates in the human body through the action of capillarity. Water from the stem reaches the branch of a tree through capillarity action. The flow of ink in a pen, capillarity action. And finally, we have also understood Poiseuille's formula with respect to capillarity. In my next session, I come up with question and answers framed on fluid dynamics. Until then, have a nice time. Thank you.